Hey guys, and welcome back. My name is Miss Danielson, and today we're having a look at square roots. I hope you joined us for our previous lesson on square numbers, because we're going to be talking about that quite a bit today as well. I'm linking it down in the description box for you below, just in case you want to have a look at that first. Let's get started. First of all, where do square numbers come from? If we think of square numbers as growing on trees, well, surely they must come from their roots then. Square rooting is the act of finding which value was multiplied by itself to give a value. So if you know your squared numbers, you should know your square roots, because squared numbers are the result of multiplying a value by itself. The square root is the value that was multiplied by itself. Suppose we have number 25 growing on this tree. What are its roots? 5 times 5 makes 25. So if 25 is equal to 5 squared, that must mean that the square root of 25 is 5. Simple, right? However, you have to remember that every positive number has two possible square roots. What could the other square root possibly be? I see positive number here in green. Maybe that's a hint about the sign. Remember when we squared negative values, the result was always a positive number? Because when you multiply a negative number by a negative number, the signs are the same. They multiply together to give a positive number. So since squaring a positive value gives the same answer as squaring a negative value with the same absolute value, that must mean that although 25 is equal to 5 squared, 25 is also equal to negative 5 squared. And remember, those brackets are important because without the brackets, we wouldn't be multiplying negative 5 by negative 5. And we can show both the positive and negative answers with this positive and negative sign. Let's try another one. 16, for example. If 16 is growing on this tree, what are its roots? What is the number that multiplies by itself to give 16? 4 times 4 makes 16. Remember, there is a positive answer and there is a negative answer. So we would write the square root of 16 is equal to either positive or negative 4. Don't forget this plus or minus sign. We're getting to a stage now where that's going to be important in order to gain full marks. What about negative numbers now? Can we square root a negative number like negative 4? Be careful, because 4 is a square number that we could square root, but negative 4 is not a square number. If you think back to our lesson on square numbers, you will realize that it is impossible to square root a negative number. To get a negative answer from multiplying two values together, those values must have opposite signs. If both of those values were positive, the result would be a positive square number. If both of those numbers were negative, the result would be a positive number. If the signs are different, we are not multiplying a number by itself. So we can't square root negative numbers. What if I took my calculator and I cheated and I tried it? What would my calculator tell me? It would say math error or syntax error, because the square root of a negative number doesn't really exist. And when I say it doesn't really exist, I mean it's not a real number. It is an imaginary number, but we won't get into that until you're at A level. What about square rooting decimal values, like 0.09, for example? Just like squaring decimal values, I don't want you to jump to any conclusions and get the wrong place value. So in order to square root a decimal value, like we did with squaring decimal values, I prefer to work in fractions. The nice thing about fractions is it lets us work with whole numbers of numerators and whole numbers of denominators, so we'll avoid making place value mistakes. So 0.09 is the same thing as 9 over 100. That's 9 hundredths. And the square root of 9 over 100 is as simple as square rooting the numerator and square rooting the denominator. So we'll do the square root of 9 over the square root of 100. And these are square numbers that you should know. Square root of 9 is 3, and the square root of 100 is 10. So the square root of 0.09, or the square root of 9/100, is 3/10, or 3 over 10. Now, if the question is given as a decimal, we prefer our answer as a decimal. So I prefer my answer as 0.3. Either way, they're both 3/10. So we could say that the roots of 0.09 are either positive or negative 3/10, because that's 0.3 times 0.3, or negative 0.3 times negative 0.3. We can think of squaring as the area inside a square of given side lengths. So here I've got a square of side lengths 5 by 5. So 5 times 5, there are 25 squares, which is why we say this is 25 centimeters squared. Alternately, we could talk about square rooting as finding the side lengths of a square if we know its area. So here I've got an area of 25 centimeters squared. I wonder how many centimeters that would be across the bottom. I see that that's 5 centimeters across the bottom. Now I wonder how many centimeters that would be up the side. I see that that's 5 centimeters up the side. That's how we fill the entire space with 25 of these centimeter squares. So the square root of 25 must be 5.
Now it's your turn for some practice. So first, what I want you to do is, without a calculator, work out the square roots of these values. Now the first 2 rows should be fairly straightforward. Just remember that when you square root a number, you could have a positive or negative answer, so make sure you write both. For the last 2 rows, we're working with decimal values here. So remember to first convert those to fractions and then square root both your numerator and denominator. And remember that your answer could also be positive or negative. For question 2, I want you to work out the side lengths of squares that would have these areas. Basically, I'm asking you what length was multiplied by itself to give these answers. For those of you who need an extra challenge, question 3 asks you to work out the square roots of these larger values. Now, this could be a bit difficult because you might not know the square roots of these big numbers, but I'm going to ask you to try to remember what we learned about factors and breaking numbers down into their prime factors. If you can break these numbers down into factor pairs where both of those factor pairs are squared numbers, you should be able to square root both of those factors and get your answer as a product of these square rooted factors. If you're having trouble understanding that, just work through questions 1 and 2 now. And when we come to taking up question 3, I'll give you a bit of a hint before I let you work it out for yourself. So go ahead and hit pause now, copy the questions, work through questions 1, 2, and give question 3 a try, and hit play when you're ready to take up your answers. I hope you had a chance to hit pause, because here come your answers. For question 1, for question 2, the side lengths should have the same unit of measure as the areas, but of course without the squared. So if the area is in millimeters squared, the side length is in millimeters. If the area is in meters squared, the side length is in meters. You don't need to convert your units of measure unless you're asked to.
For question 7, if you haven't yet done it, I'll give you the hint and hit pause and try it for yourself. First of all, 400 is a square number, but it's quite a high one. But you might notice that 400 is the same thing as 4 times 100. So for square rooting 400, try square rooting 4 and multiplying that by square root of 100. Same thing for 3,600. You should notice that that's the same thing as 36 times 100. So try square rooting 36 and square rooting 100. Same thing with 900. Try square rooting 9 and square rooting 100. Hit pause if you need a chance to do that for yourself. Let's keep going taking this up. The square root of 4 and the square root of 100 is 2 and 10. So the square root of 400 will be 2 times 10, which is 20. The square root of 3,600 is the square root of 36 times the square root of 100, which is 6 times 10. So that's 60. And the square root of 900 is the square root of 9 times the square root of 100, which is 3 times 10. So that's 30. Of course, I hope you remembered your plus minus signs. Now onto the ones below, they may not be so obvious, so factor trees might help. Let's talk through question D first, and then maybe you want to pause and try E and F the same way. Now looking at question D, I hope you notice that you could try dividing this number by 5. If I divided by 5, I get 45. Now 5 is not a square number and neither is 45. 5 is a prime number, so what I'm doing with my factor tree here is I'm breaking this number down into its prime factors. So let's try that again. 45 could also divide by 5, and that would give us 9. 5 is a prime number, but 9 is not. So let's go again. 9 can be divided by 3, and the answer is 3. Notice something nice about our final factors. 5, 5, 3, and 3. That means 225 is the same thing as 5 times 5 times 3 times 3. The square root of 225 is the same thing as the square root of 5 times 5 times 3 times 3. Note that 5 times 5 would be 5 squared, and 3 times 3 would be 3 squared. Are you thinking what I'm thinking from up here when we did the square root of 4 and the square root of 100? What's the square root of 5 squared? Must be 5. Same thing with the square root of 3 squared. It must be 3. So the square root of 225, if you didn't know it before, is 15, positive or negative 15. You can double check that by multiplying that together again. 15 times 15 does give you 225. If you want to hit pause and try E and F for yourself, we're going to do them the same way. 1,225 is a very big square number. I don't expect you to memorize it, but if you can break it down into its prime factors, you'll see that you will have pairs of prime factors, so you will be able to square root them. 1,225 can divide by 5, and the answer is 245. 245 can also divide by 5, and the answer is 49. Oh, do you notice what I notice? 49 is a square number. 49 can divide by 7, and the answer is 7. Once again, we can write 1,225 as a square number multiplied by another square number. So we can square root each of those numbers, and we'll have the square root of our original value, 1,225. It's positive or negative 35. Try question F for yourself now. We're going to go through it the same way. First, we'll do our factor tree. 196, I know it can divide by 2 because it's an even number, and that would be 98. Let me try that again. I can divide that by 2 as well because it's still an even number, and that would give me 49. This is looking familiar now. 49 is a square number. 49 can divide by 7, and the other factor would be 7. So do you know what the square root of 196 is already? I hope that you're thinking there's 2 2's there, there's 2 7's there. The square root of 196 is the same thing as the square root of 2 times 2 times 7 times 7, which is the square root of 2 squared, times the square root of 7 squared, which will be 2 times 7, 14. Don't forget plus or minus, positive or negative 14. Now, I've shown you every step of my working to make that really clear for you, but I'm sure that most of you now have got the idea of this, and you can probably just do your factor tree, see your prime factors and say, pairs of this number, pairs of that number. My square root must be the product of 2 times 7. Now, I know question 7 is a bit of a stretch, but I have definitely seen questions like this at GCSE, and I wouldn't be surprised to see them on Checkpoint either. So we'll keep practicing at it, and hopefully we'll get there. I hope you found this lesson interesting and helpful, and if there's anything that I've left a bit unclear, feel free to leave me a comment and I'll try and clarify that for you. Otherwise, it does take practice, so keep practicing and I'll see you soon.